Okay. So as you can see here, I have shared the content page of your all book. So here, Unit 1, Principles of Chemistry, and there are 10 topics, but I'm going to like concentrate them or like convert them into few topics, and from there onwards, we will be discussing about the further theory parts. So in this session, I will be giving you all the necessary stuff, right? Not going into like, like into deep theory parts or something like that. And in Unit 2, Inorganic Chemistry, and Unit 3 and Unit 4, Organic Chemistry. So by the time, like I have scheduled 6 sessions, including today. So within these 6 sessions, most of time, like we'll say like 5 sessions or something like that, right? So from the first 5 sessions, we will be able to cover all these theory parts. Okay. So for now, we'll start preparing that note. Right. So we'll start preparing the what do you call that map-like thing. Okay. So here, take out your paper. So first, we'll prepare the concept map, and yeah, we'll prepare the concept map. So just give me a few minutes. Right, we'll prepare the note. Okay. So the first topic is Unit 1. So it is going to be the principles of chemistry. So Unit 1, the principles of chemistry. You can make the note with me. Okay. So this thing, I'm going to divide it into like mainly 4 parts, right? 4 parts. So here, I'm going to divide it like this. So the first few sections will be mainly focusing on the general chemistry parts, right? So here I'm going to focus on the general chemistry. So here I'm going to discuss about the state of matter, elements, compound mixtures, atomic structure, and periodic table. So I'll just write 3 main topics, right? So first I'm going to discuss about the structure of matter. And second one about the atomic structures. And the third one about mainly about the periodic table. About the periodic table, right? Then the second topic is going to be the chemical calculation part. So here, chemical calculations, right? Chemical calculation. So here we are going to discuss calculations related to mass and volume. So these are the main two parts that we are going to discuss in the under chemical calculation part. And the third subtopic is going to be the bonding subtopic, right? So here under this section, we will be discussing about covalent bonding, ionic bonding, and metallic bonding. And the last section will be dedicated for electrochemistry, right? So here we will be discussing about electrolysis. So this is how the unit 1 uh, is going to be. So these are the main few topics that we are going to discuss, right? So here I'm not going to dive into that in-depth theory parts. So I will be like, like doing some sort of a revision thing, okay? And if you're having any trouble, as I mentioned, so please drop a message in the chat box, right? You can send me a personal chat. You can open a personal chat. You know these things, right? Okay, so you can use the chat box and yeah, right. Then, so this is for unit 1. Uh, and another thing, so since I can't hear you guys, මේක ලියා ගන්න වෙලාව ලියා ගත්තද ඔයගොල්ලෝ? ගත්තා නම් මට thumbs up එකක් දාන්න, so then I can move on to the second concept map as well. Yes. If you have finished, then just tell me. Then we can move on to the next concept map. I'll upload the note, but you guys need to prepare your own note, okay? So that's why I'm doing this thing. Like, otherwise, there's no point of like just giving a printed note or something like that, PDF, and so you need to memorize these things. Right. So shall we move on to the, yeah. So I'm moving on to the second subtopic then. So second subtopic, sorry, the second unit actually, right? Second unit, um, the concept map inorganic chemistry. So I'll write unit 1 here. And the second unit is inorganic chemistry. This is going to be our unit 2. Right. So here, this one will be divided into like 5 subtopics. So the first one will be about the alkali metals. or we can say group 1 metals. So here we will be discussing about the properties, reactions about alkali metals. And the second subtopic is going to be about group 7, which are the halogens. And the third subtopic, gases. So here we will be focusing on gases in the atmosphere. And next one will be about the reactivity series. And the last one, sorry, the next one, chemical tests. So when it comes to chemical tests, this thing will be divided into like identifying of gases. There are 5 gases to be identified at your level, in your level, right? Gases. Then we will be focusing on cations, the positive ones, and also the negative ones, right? So these ions can be like simple ions, or in some case, some sort of like complex ions as well, right? So at that time, we will be discussing about that. And the next 2 topics under this section here, titrations, again falling under that calculation part, but I'm not going to connect them, right? Calculations. So here we will be discussing about the acid-base titrations. Acid-base titrations. And from here, there will be a subsection about salts, right? So this is how the unit 2 will be going in our discussion. Okay, write down. I am preparing this concept map because like you need to have an idea that about what we are going to discuss here. Okay, otherwise like there will be so many subtopics and you will be confused with time. So you need to have an idea what we are doing here. Like within this small time, we are going to cover the whole syllabus, like 1.5 year syllabus within this few sessions, like 5 or 6 sessions. So you need to have an idea what I'm going to discuss here. Once you have finished, just give me a thumbs up, then we can move on, okay? So I will be giving you like, so this is for the whole content map. So once I started a unit, once I started one specific topic, then from there onwards also we will be preparing this concept map, right? So from there onwards, like you can, so you will be using this map to memorize the theory points. So these are just the main topics. So we can further divide them into different subtopics as well. Yes, finished. Right. Then the third topic. So that is the physical chemistry. So here we will be discussing a small thing, um, physical chemistry, unit 3. So it will be mainly divided into energetics, kinetics, and equilibrium, right? Going to be divided into actually energy. There's no such topic called energetics. Once you learn for like advanced level and for further levels, then you will get an idea like there's no such topic as energetics. It will be falling under thermodynamics, right? So the thermodynamics is a vast field of study, right? So for the moment I'll write it as energetics. So here we will be discussing about those enthalpy values and yeah. So I'll write an energetics as well here. And the next one, kinetics. So here we will be discussing reaction. Kinetics are mainly focusing on the rate of a reaction. Rate of a reaction. And the last one about equilibrium. And here about reversible reactions and equilibria. So here I'll write reversible reactions. Reversible reactions. Right. Then the last main topic, main unit is organic chemistry. Right. So here we can divide into four major subtopics. First one will be introduction to organic chemistry. Introduction to organic chemistry. Right. Introduction to organic chemistry. What has happened? Mic is not working. Right. Can you hear me now? Yeah, can you hear me now? It's yeah, yeah. Wait, wait. Uh, mm, how about now? Just give me a few minutes, huh? Can you hear me now? Right now it's okay. Right now it's okay. So the first part will be uh, organic chemistry, and then we will be discussing about different organic compounds. We will be discussing about different. All right, before going into that, the crude oil section will be a different one. And afterwards, we are going to discuss about few compounds, right? Few compounds. So here I'll divide this into organic compounds. From there onwards, this specific branch can be divided further into alkanes, alkenes, alcohols, carboxylic acids, and also to another group, esters. And finally, there's a specific branch called polymers, right? So this is the organic chemistry unit concept map. Okay, write down. Right, finished. Shall we move further? Okay. Right, so we'll start from the very first topic, which is going to be the first unit, principles of chemistry. So here the general concepts will be discussed here, structure of matter, atomic structures, and about the periodic table, right? So write down the first subtopic, unit 1, okay, unit 1, principles of chemistry, and under that, structure of matter. So this is going to be unit 1, structure of matter. Right. Okay, so you can prepare the note with me, okay? So when it comes to matter, first of all, you need to identify what is matter, right? So in order to be a matter, there are two conditions to be fulfilled, right? Must be having a mass, must be having a mass, and the second condition must occupy space, right? Must be like having a volume or something like that, okay? In different terms, you can write it like this. So a matter means any sort of substance which is having a mass and occupying the space in the environment. And so this matter can be divided into different subcategories. So this one is depending on the organization of particles, how the particles are organized, right? Organization of particles. So the first matter, solid, second matter, liquid, and the third one, gases, right? Gases. Actually, there's a fourth type as well, but for your level, there's no need of knowing that, right? So for your level, just know that there are three main subcategories for the matter, right? There are three main subcategories. There's no need of knowing the fourth one, right? So we are having solid, liquid, and gas, okay? And these are the main concepts, right? Then you must know the interconversions, right? And here I will discuss like solids are, we know these things, right? They are tightly packed or arranged in a pattern like this. And liquids, they can be existing like this. The spaces are somewhat higher than the solid matter, and gases matter like this. And the main points that you remember here is gases, they are having random motion, right? Random motion with high speed. Okay, random motion with high speeds. So if they are asking you to like then අපි papers ගොඩක් කරන්නේ එතකොට අහලා තියෙනවා වගේ questions මතක වෙනවා ඔයගොල්ලන්ට, right? So therefore you need to remember that two places, and here for the solids you are having vibrational movements. Okay, vibrations. So remember those few things. Yeah, make it a diagram. You can write it like this. So we are preparing something like a short note or something like that. Okay, right. You can prepare it with me, and we'll do something like this. Okay. So if possible, prepare it with me, and මම මෙහෙම වෙලාව දෙන්න නැතුව කරගෙන යන්නම්. මොකද නැත්තම් එහෙම වුණොත් එහෙම අපිට පොඩ්ඩක් ටයිම් එක මේ මැනේජ් කරගන්න බැරි වෙයි. දැන් ඔයාලට මම කොහොමද රෙකෝඩින් එක මේ ලින්ක් එකක් දෙනවනේ, රෙකෝඩින් ලින්ක් එකක්. එතකොට මේ එක ආයෙ රිෆර් කරන්න. ආයෙ රිෆර් කරලා ඔයාලට පුළුවන් ඒක ඩවුන්ලෝඩ් කරගන්න පුළුවන්. ඩවුන්ලෝඩ් කරගෙන හරි ඒ විදිහට බලලා මේ බලන ගමන් ඒ කියන්නේ ස්ටෙප් බයි ස්ටෙප් ඔයගොල්ලෝ හදාගෙන යන්න. දැනට එහෙනම් මෙහෙම කරගෙන යන්න අපි මම මේක ඔක්කොම ඩිස්කස් කරගෙන යන්නම්. මොකද නැත්නම් අපිට ටයිම් එක මදි වෙනවා. මේ මේක හොඳට අහගෙන ඉන්න, ඕන දේවල් නෝට් කරගන්න, එන්ගේජ් වෙන්න මේ ඩිස්කෂන් එකත් එක්ක. එතකොට මේ ඒ විදිහට කරගමු. අපි නෝට් එක හිමීට හදාගමු. ඔයාම හදාගන්න පටන් ගන්න. මේ අර විදිහට බලමු. හරි? වීඩියෝ එක බලලා කරන්න. මම දැනට ඉස්සරහට යනවා. නැත්නම් මේ අපිට වෙලාව පොඩ්ඩක් මදි වෙයි. right? ඒක ප්‍රශ්නයක් නෑ නේද? මට චුට්ටක් කියන්න chat එකට දාන්න එක්ක thumbs up එකක් හරි දාන්න. එහෙම අවුලක් නැද්ද මේ method එක? නැත්නම් ඔයගලන්ට මේ time එකේම මේක කරගෙන යන්න ඕනේද? All right. So we'll do something like that. Okay. Right. Good. Right. Then the main next part is the interconversion, right? So you need to know the interconversion. These are some simple things. Ne? So solid matter, liquid, and gaseous matter. So interconversions, solid into liquid, that is known as melting. liquid into gas, that is known as boiling. And you need to know the right. You need to know the other way around as well, right? Okay. Right. So this can be written as boiling or evaporation. Huh? Both are correct. And the other way around, this is known as freezing. And gas into liquid, that is condensation. And there are some special ones as well, right? This thing, the solid directly turning into gas, that is known as sublimation. And the gas turning into solid directly, this is known as deposition. And there are some important terms as well, right? So melting point and boiling point. So melting means the solid, right? Specific solid turns into its liquid. So melting point, the temperature, it lies here, right? So for the melting point, we can say the specific temperature where the solid turns to its liquids, right? The specific temperature where the solid turns to its liquid, that is known as the melting point. And for the boiling point, it will be here, right? So the boiling point means the specific temperature where a liquid turns to its gas, where the right. Then okay. So so you need to know about the interconversions, and also you need to know about the boiling and evaporation. So we cannot say those are the same things, right? They are not the same ones, but there are some differences, right? You need to find them. So the first question here, right? Boiling versus evaporation, the difference. So this is for homework. You need to find out this, right? Boiling versus evaporation. Then there are some concepts about like how the mass is transferred. So here that concept is described in using diffusion, right? Then the next concept is about diffusion. So this is actually a one concept of mass transfer, right? Mass transfer के एक concept එකක් තමයි මේ diffusion කියලා කියන්නේ, right? So මේකේ අහන්න පුළුවන් හොඳම question එක තමයි අර ammonium chloride හැදෙන concept එක, right? So find out the definition and the experiment for gases. So this experiment, like most of the time, they have asked this in your exams, right? Diffusion එක experiment. So the experiment is you are reacting ammonia gas with HCl gas, and you will be getting ammonium chloride, a solid gaseous, a solid white color precipitate. So here I'll discuss this quickly. So we are using the glass tube like this, right? So at each end you are having this cotton wool dipped in ammonia or HCl. So we'll take, this is to be the cotton dipped in ammonia, and this is the cotton dipped in HCl, right? So what will happen is that here you will be getting ammonia gas particles, and here you will be getting HCl gas particles, right? You will be getting HCl gas particles. Then what will happen? These gas particles will move along the tube like this, right? They will move along the tube like this until they are met, right? So at the place that they are going to meet, you will be getting this ammonium chloride precipitate, right? You will be getting that ammonium chloride precipitate. So it won't be at the middle place, right? The reason is, so if we consider about ammonia, the molecular weight is something like 14 plus 3. This is for nitrogen and this is for 3 hydrogen atoms. So altogether 17 grams per mole. And for chlorine, it will be 1 plus 35.5, which is 36.5, right? So HCl is the heavier gas, right? So remember that speed of gas particles will be inversely proportional to its mass, right? Speed is inversely proportional to mass. බර වැඩි වෙන්න එයාගේ ස්පීඩ් එක අඩු වෙනවා. Okay, බර වැඩි වෙන්න එයාගේ ස්පීඩ් එක අඩු වෙනවා. So therefore what will happen? HCl is the heavier gas. So therefore these gas particles will be moving a small distance, right? So which means this precipitation will occur near to HCl, right? Somewhere here. So we can say this is the place where NH4Cl is going to be made, right? This is the place where the HCl, NH4Cl is going to be made. Okay. So remember this practical. මම හිතන්නේ last paper එකෙත් මේ වගේ question එකක් මේ ළඟදී කරපු paper එකෙත් තිබ්බයි. කියන්නේ 2025 වල yeah, 2025 or something, somewhere like that, right? So, and another thing, so please go through these papers once again, the papers that we completed. So please go through them and remember this point as well, right? Speed of gas particles will be inversely proportional to its mass, right? Then we need to discuss about the solubility of solids, right? Solubility of solids. So a solution will be made by the solute and the solvent, the mixture, right? So solute කියන්නේ අපේ mixture එකේ දිය කරන එක්කෙනා, solvent එක කියන්නේ අපි දිය කරන්න ගන්න එක්කෙනා, liquid එක, right? So for example, let's say I'm going to prepare a sugar solution, right? I'm going to prepare a sugar solution. So the solute will be sugar particles, right? Sugar, and the solvent is going to be water, right? Not only liquid solutions, we can prepare even gas solutions as well, and in some cases like solid solutions as well. For example, like if we consider an alloy, right? Alloy එකක් consider කරොත් මේක ඇවිල්ලා ඒ solution එක mixture එකක්. So there also you are having the solute and the solvent. So in that case, the solvent will be the metal that we are having a higher percentage, right? වැඩිපුර අපි use කරන metal එක තමයි එතන solvent එක වෙන්නේ, right? Okay, so solubility means how much it can be dissolved, right? The general idea is how much of amount can be dissolved in water at a given temperature, right? At a given temperature. How much of the solid can be dissolved at a given temperature. So here solubility curves will be discussed. So please refer the textbook there, right? Okay. So there are some calculations as well, and I'll give you the graph, right? Solubility versus temperature. So in this case, for the y-axis, we are using the solubility. And here we are using the temperature in Celsius. So most of the time, the graph is going to be a straight line, okay? It will be like this. So which means, right, the final conclusion, the summary of this is that solubility of a given solid, right, solubility will be increased with increasing temperature. So that is the final outcome, right? Solubility will be increased with the increasing temperature. Solubility will be increased with the increasing temperature. So that is the final outcome, right? So there are some calculations, so please go through them. And the next subtopic is the elements, compound, and mixtures, right? So here I'm not going to give you all the theory parts. So you need to find out the definitions for element, then compound, what is meant by a mixture, right? You need to find out. Those are for homework. And the specific definitions for melting points. Boiling point, melting point, and boiling point. Okay, right. Then there's a special subtopic, separation techniques, right? Separation techniques. Separation techniques. So when it comes to separation techniques, we are using different sort of separation. So you are having a mixture and you need to separate, like let's say the solute or the solvent, right? So in order to separate that, we are using different sort of techniques. We are using different sort of techniques, right? So when it comes to separation techniques, yeah, we can prepare it here. Right, separation techniques. So I'll start from the smallest one or the easiest one. So the first one is the filtration. First one is the filtration. So for filtration process, we are like, so we need to identify what sort of a solution that we are going to use in this separation, right? So depending on the solution, we need to choose the separation technique correctly. So here we are going to use, let's say, uh, something like this. Um, so we'll say something like this, okay? So you are having a solid and a liquid in the mixture, right? You are having a solid and a liquid. ඒ කියන්නේ ඔයාට හොඳට පේන්න තියෙනවා solid එකක්. මොකක් හරි precipitation එකක් තියෙනවා. අපි තුන් මේ වගේ. So ඔයාට වතුර sample එකක් තියෙනවා. water sample එකක් තියෙනවා. ඒ water sample එකේ observable ඒ කියන්නේ ඇහැට පේන මොකක් හරි precipitation එකක් තියෙනවා. අපි තුමු ගල් වැලි තියෙනවා කියලා. Right? So you need to extract water, right? එහෙම නැත්නම් අර ගල් ටික එළියට ගන්න ඕන. ඉතින් අන්න ඒ වගේ එකට තමයි අපි filtration process එක use කරන්නේ. So the filtration setup will be වැඩි දේවල් ලියන්න ඕනේ. මම නිකන් setup එක ඇඳලා පෙන්නන්නම්. So here you are having a funnel. Okay. Then you have a beaker or any sort of equipment there, right? And you are placing a filter paper in your funnel like this. So then you are going to add the solution, right? The mixture that you have. So what will happen is that these solid particles will be remained here and the filtered solution will be collected at the bottom, right? So for this, it is known as the filtrate, and the remaining particles, they are known as the residue, right? Filtrate and the residue, filtrate and the residue. So this is the most simplest method, right? Then the next method is the crystallization. Crystallization, right? So for this, we are using, let's say, so make a solids දෙකම mix වෙලා තියෙන්නේ, right? ඒ කියන්නේ අපි තුන් මෙන්න මේ වගේ example එකක්. sodium chloride වගේ solution එකක් ගන්න පුළුවන්, right? sodium chloride වගේ solution එකක් ගන්න පුළුවන්. අපි මෙහෙම කියමු. ඒ කියන්නේ දැන් sodium chloride solution එක ගත්තොත් එහෙම ඔයාලට ඒකේ observable particles නැහැනේ. observable particles නැහැ. clear solution එකක් තමයි තියෙන්නේ, right? අපි ඒක ලියමු කමන්නේ clear solution කියලා. a clear solution. මම මේක example එක ලියන්න. example sodium chloride. right? so මේකේ method එක වෙන්නේ අපි solution එක මෙන්න මේ වගේ evaporating dish එකක් වගේ bowl එකකට use කරනවා. ඔව් මේකට කියන්න පුළුවන් evaporating dish කියලා. ඊට පස්සේ අපි glass rod එකක් use කරන දැන් solution එක මේක ඇතුලේ තියෙනවා, right? solution එක මේක ඇතුලේ තියෙනවා. ඊට පස්සේ මෙයාගේ glass rod එකකුත් අපි use කරනවා. මේ solution එක ඊට පස්සේ අපි heat කරනවා. So now what will happen? The solute, sorry, the solvent actually, right? The solvent will evaporate. The solvent will evaporate and the particles, right? The solute particles will be remained in the dish, right? එතකොට yes මේකේ මොකක්ද ලියන්න බලන්නේ solvent evaporated and the solute remained in the dish, right? So දැන් මේක අහන්න පුළුවන් මේක different technique එකක්ද නැත්නම් same technique එකක්ද කියලා. But මේකේ මේ මොකද්ද difference එකක් තියෙනවා, right? So in the second technique, filtration is the first one. Second one is crystallization. So filtration එකේදී අපිට කියන්න පුළුවන් the samples can be like can be taken for further analysis as well, right? අපි හිතමු දැන් මේ විදිහට දැන් අපි අපේ filtrate එක මේ filtration එකට ආවම filtrate එකේ මොන හරි තියෙනවා. අපිට මේ filtrate එක තව ඉස්සරහට මේ analysis වලට use කරන්න පුළුවන්. right? තේරුණාද? දැන් ඒ වුණාට crystallization එකට ආවම අපි මේ heat එක දුන්නට පස්සේ solvent එක vaporize වෙලා නැති වෙලා යනවනේ. එතකොට අපිට තව ඉස්සරහට තියෙන මොන හරි කියන්නේ solvent එකේ තව තිබ්බා හරි කියලා තියෙන දෙයක් මේ ඇනලයිස් කරන්න නැහැ. අපිට මොකද sample එක මේ destroy වෙලා තියෙනවා. right? අන්න ඒකින්ද මෙතන පොඩි difference එකක් තියෙනවා. මම මේකෙම මෙතනම ලියන්නම් solvent එක destroy වෙලා යනවා කියන එක. right? Solvent vaporizes, so therefore solvent uh, solvent will be destroyed. right? එතනම idea එක ඔලුවට ආවා කියලා. right? ඒ කියන්නේ අපිට තව ඉස්සරහට further analysis වලට මෙතන මේ sample එකක් නැති වෙනවා. ඒ කියන්නේ අර crystallization එකේ හැදිච්ච crystals ටික විතරයි ඉතුරු වෙන්නේ. ඒ කියන්නේ අර ඉස්සරලා එකේ වගේ residue එකක් විතරයි ඉතුරු වෙන්නේ. residue එක විතරයි analyze කරගෙන යන්න පුළුවන් මේ ඉස්සරහට මේ අර ඒ solution එකේ තිබ්බ අනිත් දේවල් ටික අපිට ගන්න බැරි වෙනවා. මේ අර crystals හැදෙන්න පුළුවන් දේවල් ටික විතරයි මේ right? crystals හැදෙන්න පුළුවන් දේවල් ටික විතරයි මෙතන ඉතුරු වෙන්නේ. ඉතුරු ටික අපිට ඇනලයිස් කරගන්න බැරි වෙනවා. right? ඔතන ඩිෆරන්ස් එකක් තියෙනවා. right? then ඊට පස්සේ අපිට තියෙනවා මොනවද simple distillation and the fractional distillation. මම මේකේ chart එක මේ විදිහට පල්ලෙහාට ඇදගෙන එන්නම්. මොකද මේක continuous යන එකන්නේ. ඔන්න ඔය විදිහට එකක් එනවා. ඊට පස්සේ අනිත් එක එනවා අපේ මොකද්ද fractional distillation එක. මම මේ එක branch එකම ආපහු බෙදන්න. එතකොට ඔයගොල්ලන්ට easily මතක තියාගන්න පුළුවන්. right? So මේක distillation branch එක. but actually distillation branch එක දෙකකට නෙමෙයි බෙදෙන්නේ. හොඳට මතක තියාගන්න distillation there are different types of distillations, right? And in your LLs we will be discussing about steam distillation as well, which means like we will be using a current a steam current, right? So එච්චර දේවල් ඕනේ for the moment, just remember this, right? Distillation. So here it will be divided into two: simple distillation and the other one simple distillation and the other one will be fractional distillation. Right. So the main difference here is fractional distillation will be boiling point dependent one, right? It will be a boiling point dependent one. So something like this, let's say, right. Setup එක වෙනස් මම එක setup එක නම් අඳින්නේ නැහැ ඔයගොල්ලෝ මතක තියාගන්න. So if it is going to be boiling point dependent, then definitely we need to measure the temperatures, right? Measure the temperatures. So therefore we need a thermometer in the setup, right? We need a thermometer in the setup, right? So which means, so let's say something like this, right? You are having for the simple distillation, again we are using sodium chloride solution. So you are having the solution here, right? Sodium chloride, and you are going to heat it. So what will happen is that, right, water will be evaporated, right? Water will be evaporated, and the sodium chloride crystals will be remained at the bottom, right? So here you will be having sodium chloride crystals, right? So this method is used to extract water actually, right? So from there onwards, we can analyze water whether it is pure or not. And if it is the fractional distillation, so here this will be boiling point dependent, right? So let's say something like this: you are having a mixture of alcohol dissolved in water, right? For example, let's say this one is having the boiling temperature of 78, and this one, the boiling point water, the pure water, boiling point will be 100, right? So in the mixture, right, we cannot clearly identify they are mixed with each other, right? Mixed with each other, right? Then what will happen? We are going to heat it, right? So let's say at a temperature around 60, nothing happens. And if we increase the temperature furthermore, and when it is reached to 78 degrees, right? 78 degrees, now what will happen? The alcohol will be evaporated, right? Alcohol will be evaporated, but the water won't, right? Water වලට මොකද තාම 100 celsius reach වෙලා නැහැ. එයාට gas phase එකට යන්න නම් අනිවාර්යෙන් 100 celsius එන්න ඕන. right? ඊට පස්සේ මේක තවත් temperature එක increase කරන් යනවා. එතකොට අපි හිතමු මේක eventually 100 වලටම ආවා කියලා. So by this time all the alcohol ඉවර වෙලා තියෙනවා, right? ඒ තැනට එද්දි alcohol ඔක්කොම ටික මේ evaporate වෙලා තියෙනවා. එතකොට මෙන්න මෙතෙන්ට ආවට පස්සේ මොකද වෙන්නේ? දැන් water ටිකත් evaporate වෙන්න පටන් ගන්නවා. එතකොට අපි මෙච්චර දුරකට එන්නේ නැහැ practical එකේ, right? මෙච්චර දුරකට එන්නේ නැහැ. මොකද අපිට extract කරන්න ඕනේ pure alcohol නම් අපි පුළුවන් තරම් මෙයාව මෙන්න මේ 78 degrees වල fix කරලා තියාගන්නවා, right? 78 or something like 78 79 region එකේ තමයි තියන් ඉන්නේ. ගොඩක් කාල 78 වලම exact amount එකේ තියන් ඉන්නවා, right? එතකොට මොකද වෙන්නේ? අපිට මෙන්න මේ alcohol විතරයි evaporate වෙන්නේ. water evaporate වෙන්නේ නැහැ, right? අන්න ඒක extra point එකක්, ඒක මතක තියාගන්න special point එකක්. and මේකෙන් තව questions අහන්න පුළුවන් අර condenser එක ගැන. ඇයි water in එකයි water out එකයි මේ විදිහට වෙනස් වෙන්නේ කියන එක, right? ඒක චුට්ටක් මතක තියාගන්න. මේකේ තව special points දෙකක් තියෙනවා. මම ඒකත් දෙන්නම්. so මෙතනින් මේ විදිහට අපේ gas එක මොකක් හරි එනවනේ. steam එක හරි vapor එක. අපි කියමු vapor කියලා. right? එතකොට මේක ඔන්න ඔය විදිහට තමයි direct වෙලා යන්නේ. එතකොට මේක enclose වෙන විදිහට මෙන්න මේ glass tube එක තියෙනවා. right? glass tube එක ඔන්න ඔය විදිහට තමයි තියෙන්නේ. මේවා මම ඔක්කොම theory classes වල කියලා දුන්නා. ඒ උනාට දැන් ඉතින් ආයෙ චුට්ට මම මතක් කරලා දෙන්නම්. ඔන්න ඔය විදිහට තමයි tube එක තියෙන්නේ. right? so එතකොට අපි මෙන්න මෙතනින් තමයි water in එකක් දෙන්නේ. water out එක set කරන්නේ මෙතෙන්ද. right? ඒකට reason එක තමයි so අපි දැන් water fill කරන්න ඕනේ මෙතනින්. එතකොට ඒ ටික මෙන්න මෙතෙන්ට එකතු වෙලා එතනින් ඉඳන් තමයි මේක ඔන්න ඔය විදිහට fill වෙලා එන්නේ. fill වෙලා මෙතනින් එළියට එනවා. ඔන්න ඔහොම. right? දැන් බැරි වෙලා හරි අපි මෙතනින් ඉන්න එක දුන්නොත් ඒක කෙලින්ම ඊට පස්සේ drip වෙනවා මෙතෙන්ද. මේ ටික fill වුණාට පස්සේ මෙතනින් ඔහොම එළියට එනවා. right? simple දෙයක්. ඒක තේරෙනවනේ ඔයගොල්ලන්නේ. මෙතනින් යටින් දුන්නොත් මෙතෙන්ද fill වුණා. fill වෙලා ඊට පස්සේ තමයි මුළු එකම මෙන්න මේ විදිහට fill වෙලා මෙතනින් තමයි එළියට එන්නේ. ඒ කියන්නේ බලන්න අර black color tube එක ගොඩක්ම වතුර වලින් වැහිලා තියෙන්නේ. right? බැරි වෙලා හරි මෙතනින් fill කරොත් එහෙම මෙතනින් fill කරොත් මේ ටික drip වෙලා ඔහොම ඇවිල්ලා මෙතන fill වෙලා ඊට පස්සේ මෙතනින් අර displacement can එකකින් එළියට යනවා වගේ ඔහොම යනවා. right? ඔන්න ඕක තමයි theory එක. right? එතකොට ඒ reason එක high. right? එක එකක්. දෙවෙනි එක මෙන්න මේකේ efficiency එක වැඩි කරන්න පුළුවන් තව method එකක් මොකක්ද කියලා. so instead of using this linear, right, or straight lined glass tube, we can use something like this. වේප එක මෙන්න මේ විදිහට එනවා. ඇවිල්ලා මම මේ inner glass tube එක ඔන්න ඔය විදිහට පොඩ්ඩක් නිකන් මේ හෙලික්ස් එකක් වගේ මේ ස්ප්‍රින්ග් එකක් වගේ ඔන්න ඔය විදිහේ ෂේප් එකක් හදනවා. දැන් මේක ඇතුලේ තමයි අර glass tube එක enclose වෙලා තියෙන්නේ. ඔන්න ඔය විදිහට. ඔන්න ඔහොම. right? මේක නම් තාම අහලා නැහැ. හරි? මේක අහලා නැහැ. ඒකින්ද මම වැඩි ඉතින් පුෂ් කරන්නෙත් නැහැ මේක මතක තියාගන්න කියලා. but in case බැරි වෙලා හරි යවුවොත් එහෙම ඔන්න ඔය විදිහට යන්න පුළුවන්. ඒතකොට මේකේ මොකද වෙලා තියෙන්නේ? මෙන්න මේ දැන් මේකේ water fill වෙනවානේ. right? water in මෙතනින් water out. right? so water ටික මෙතනින් fill වෙලා පටන් ගන්නවා. ඒ වුණාට වේප එකට යන්න තියෙන distance එක මොකද වෙලා තියෙන්නේ? මේ අර මේකෙදි වේප එක යන්නේ කෙලින්ම මෙහෙම මේකෙදි වේප එක යනවා ඔන්න ඔය විදිහට. එතකොට අපි මේක ස්ට්‍රෙච් කරලා නැන්දොත් එහෙම මෙන්න මෙයාගේ වේප එකට travel කරන්න කියන distance එක වැඩි. ඒ කියන්නේ එයාගේ අර waterත් එක්ක තියෙන contact time එක වැඩි වෙනවා. right? මම ඒක mention කරන්න මෙතන. contact time with water, or we can say the cooling process, right? The cooling process එක වැඩි වෙලා තියෙනවා. අර විදිහට අපි අර glass tube එක පොඩ්ඩක් වෙනස් කරොත්. right? ඊට පස්සේ final separation method එක මම මේ graph එක sorry මේ lines ටික පොඩ්ඩක් ඇදලා ගන්නම්. එතකොට final separation method එක අපිට තියෙනවා paper chromatography. right? paper chromatography. so මේකේ specialized paper එකක් තියෙනවා. මේකට අපි කියනවා TLC කියලා කියනවා. right? thin layer chromatography. TLC කියලා කියනවා. so here මේකේ තියෙනවා special paper එකක්. මේකේ එක side එක coating එකක් දීලා තියෙනවා. right? coating එකක් දීලා තියෙනවා. ඒ coating එක දීලා තියෙන side එක තමයි අපි use කරන්නේ අපේ මොනවද chromatography method එකට. so මේකේ අපි pencil එක use කරනවා මේවා දන්නවනේ ඔයගොල්ලෝ. right? එතකොට මේකේ line එකක් ඇඳ ගන්න ඕනේ. ඊට පස්සේ අපි stop කරන්න line එකක් ඇඳ ගන්න ඕනේ. ඊට පස්සේ මේකේ තමයි අපි අර අපේ මොනවා හරි separate කරගන්න ඕන solution මෙන්න මේ විදිහට තියලා ඊට පස්සේ මොකද්ද මේකේ water level එක නැත්තම් water level කියලා මම දන්නවා. water level එක මෙන්න මේ විදිහට යටට තියෙනවා. right? එතකොට මේකේ ඔයගොල්ලෝ මතක තියාගන්න ඕනේ මොනවද මේකේ ගොඩක්ම අහනවා wrong approaches මොනවද කියලා. right? අපි කරපු ඒ ගැන් papers කරපු හින්දා දන්නවා මේවා. right? එතකොට wrong approaches විදිහට ගන්නවා මොනවද using of ink pens. right? using of pens. ඊට පස්සේ water levels වල වැරදි මොනවද අන්න ඒ වගේ දේවල් අහනවා. right? අන්න ඒවා චුට්ටක් බලා ගන්න. ඊට පස්සේ මොකද වෙන්නේ මේක ඔන්න ඔය විදිහට උඩට යනවා. එතකොට separate වෙනවා. මේවත් උඩට යනවා separate වෙනවා. ඔන්න ඔය විදිහට separate වෙනවා. ඊට පස්සේ අපිට මෙයාගේ calculate කරන්න ඕනේ RF factor එක. right? so always remember RF value must be below than 1. right? if you are getting more than 1 then it is wrong. right? එක වැරදි. එක අනිවාර්යයෙන්ම RF factor එක 0 point something එන්න ඕනේ. එහෙනම් ඔයාලට 1 point something එනවනම් ඒ කියන්නේ ඔයා අනිත් පැත්තට අරන් තියෙන්නේ. ට්‍රක් ගාලා වැලියක වෙනස් කරන්නයි තියෙන්නේ. right? එතකොට ඒකේ ගන්නේ RF එක ගන්නෙ මෙන්න මේ total distance එක, right? අපි හිතමු spot එක මෙන්න මෙතෙන් දෙන්නේ කියලා, right? මම මේක දාන්නම් DA කියලා, මේක දාන්නම් D total කියලා. එතකොට RF factor එක ගන්නේ DA over DT, right? ඒ කියන්නේ solution එකෙන් ගියපු දුර අපේ spot එකෙන් ගියපු දුරෙන් බෙදෙන්න ඕනේ, right? ස්පොට් එක ගියපු දුර සොලියුෂන් එක ගියපු දුරෙන් බෙදෙන්න ඕනේ. කියන්නේ අපි ප්‍රැක්ටිකල් එක නවත්තන්නේ මෙන්න මෙතෙන් එනකල් මේ පේපර් එක පොඩ්ඩක් වෙට් වුණාට පස්සේ තමයි. right? normally අපි මේක 24 hours වගේ තියලා තියෙනවා, මම එකක් මෙන්ෂන් කරන්න. normally 24 hours, right? සමහර ඒවා තියෙනවා ඊටත් කලින් ඉවර වෙන දේවල් තියෙනවා. අපි චුට්ටක් මේක අර ඒ කියන්නේ ප්‍රැක්ටිකල් එකේ ඉන්වෝල්ව්, ඒ කියන්නේ මේක දාලා නිකන් තියලා ගිහිල්ලා හරියන්නේ නැහැ. සමහර ඒවා තියෙනවා, සමහර ඒවා එහෙම බෑ. හරි. එතකොට මේකේ හිතන්න ඔයාගේ ස්පොට් එක මෙන්න මෙතෙන්ද ඇවිල්ලා නැවතිලා තියෙනවා කියලා. එහෙනම් මේ ඩිස්ටන්ස් එක බෙදෙන්න ඕනේ මෙන්න මේ ඩිස්ටන්ස් එකෙන්, right? මේ total length එකෙන්. මොකද සොලියුෂන් එක මෙතෙන් එනකල් යනවා. අපේ ස්පොට් එක මෙතන නැවතුණාට සොලියුෂන් එක මෙන්න මෙතෙන් එනකල් ඇවිල්ලා තමයි නවතින්නේ. අන්න ඒක තමයි assumption එක, right? නැත්නම් normally TLC කියන්නේ අර අපිට නිකන් මේ දවසක් වගේ තියන්න ඕනේ නැති ඒවා ගත්තොත් එහෙම අපිට ටක් ගාලා මෙන්න මෙතෙන් ආවට පස්සේ මේ ප්‍රැක්ටිකල් එක නවත්තලා ගන්න පුළුවන්, right? ඒක අපිට clearly observable. කියන්නේ මෙන්න මෙතෙන් දෙනකල් එද්දි මේ ඔක්කොම ටික වෙට් වෙලා තියෙන්නේ, right? ඒක හොඳට මතක තියාගන්න. RF calculations ඒක නිකන් ඒක චුට්ටක් ආයෙ රිෆර් කරන්න. papers වල අපි ගොඩක් කරා මේ RF questions මාර ලේසි. හරි. right. ඊට පස්සේ අපිට කතා කරන්න තියෙනවා atomic structure එක ගැන. atomic structure, isotopes and isotope calculations, then periodic table. Okay. right. මම ටටක් ගාලා කතා කරගෙන යන්නම්. right. ඊට පස්සේ අපිට තියෙන atomic structure. normally atom එක, so it can be divided into main two sections, the nucleus and the subatomic particles. Nucleus and the subatomic particles, right? So nucleus is the centralized mass. Centralized mass. Subatomic particles are the particles that you can find in the atom, right? So they can be divided into main three categories, but remember there are so many subatomic particles like positrons, neutrino, likewise, right? So for your level, it's enough. Just there are three particles, right? So you have protons, neutrons, and electrons. I'll write it like this, right? So protons are the positive particles, neutrons are neutral, electrons are the negative particles, right? Okay, so and another thing, so if we consider about the structure of the atom, so first you have the nucleus like this, right? So inside this nucleus you have protons and neutrons, right? You have protons and neutrons. Then there are some other cases as well, something like this, right? Right. And around the nucleus, you have energy levels. Right. So these are known as the energy levels. Right. So this is named to be the first energy level, second, third, fourth. Likewise, there are energy levels, right? And the electrons will be orbiting in these levels, right? You have electrons. So the first level can occupy maximum of 2. And the next level, 8. Likewise here, the electrons will be orbiting around the nucleus. So this is the most accepted way, right? And then you need to know the differences between these particles, right? Protons, neutrons, and electrons. So I'm just going to prepare the table. You need to memorize it. I'm not going to give you all the details here, right? So this is the table that you need to memorize. First one, you have the character feature here. So for protons, neutrons, and electrons. So the first character, you need to remember the specific symbol, the display, right? So for protons, we are using 1 plus 1 and letter P there. And for neutrons, it will be 1, 0, N. For electrons, it will be 0 minus 1 E, right? මේක මත තියාගන්න. මේ මෙතඩ් එක මත තියාගන්න. මෙතනින් ගොඩාක් ඩීටේල්ස් ඔයාලට හම්බ වෙනවා, right? ඒකින්ද display එක මත තියාගන්න හරියට. symbol එක මත තියාගන්න. Then the second one, where you can find, right? I'll say occurrence, right? Occurrence. So මේ දෙන්නම එකම තැනක ඉන්නේ. නියුක්ලියස් එකේ මෙයාලා ඉන්නේ energy levels වල. ඊට පස්සේ third එක relative mass, fourth එක relative charge. relative mass හැම වෙලේම මත තියාගන්න. අපි දැන් symbol එකක් පෙන්නද්දි අපි හිතමු අපේ chemical එකේ මොකක් හරි element එකේ symbol එක මෙන්න මෙයා කියලා. So අපි මෙන්න මෙතන උඩින් ලියන්නේ එයාගේ mass එක, right? ඒක තමයි normal convention එක. අපි ඉස්සර කතා කරනවා මෙතන mass number එක එන්නේ. ඊට පස්සේ මෙතන එනවා atomic number එක, right? ඔක තමයි normal convention එක. ලියන හරි method එක. ඒ වුණාට මේකේ පොඩි මෙන්න මෙහෙම දෙයක් තියෙනවා. ඔයගොල්ලෝ චුට්ටක් හිතුවොත් එහෙම දැන් මේ atomic number එක, right? දැන් මේ කියන්නේ දැන් ඉස්සරහට ඕන එකටත් එක මම මේ එක්ස්ප්ලেইন කරගෙන යන්නේ. මෙතන තියෙනවා number of protons කියන එකනේ, right? එතකොට protons කියන කට්ටිය ඒගොල්ලෝ positively charged, right? ඒගොල්ලෝ positively charged. ඒ කියන්නේ අපිට කියන්න පුළුවන් මෙන්න මේ atomic number එක use කරන්න පුළුවන් අපිට එයාගේ charge එක calculate කරන්නත්, right? චුට්ටක් හිතලා බලන්න. atomic number කියන්නේ number of protons ගන්නවා. ඒතකොට protons වලින් තමයි charge එක එන්නේ. මොකද මේ nucleus එකේ ඉන්නේ protons and neutrons, right? nucleus එකේ ඉන්නේ protons and neutrons. ඒතකොට protons වල මොකද්ද? protons වලට positive charge එකක් තියෙනවා. neutron වල charge එක 0, right? එතකොට all together positive and 0 charge. ඒ කියන්නේ directly ඔයාට atomic number එකකින් ගන්න පුළුවන් මෙයාගේ charge value එක, right? So ඒකයි මම කිව්වේ මෙන්න මේ symbol එක මත තියාගන්න කියලා, right? symbol එක මත තියාගන්න. එතකොට upper number එක කියන්නේ mass එක, right? relative mass එක. මෙයාගේ 1 1 0, right? 1 1 0. හැබැයි මේකේ exact value එක මේ 0 එන්න හේතුව තමයි reason එක මෙයා ඇවිල්ලා 1/1836, right? ඔයා ඒක calculate කරලා බලුවොත් එහම ආට 0 කියලා value එකක් එයි. relative charge එක ඉන්නේ යට number එකෙන්. So relative charge +1 0 -1, right? easy. ඒකයි මම කිව්වේ ඒ symbol එක මතක තියාගන්න. symbol එක මතක තියාගත්තොත් ඔයාලට මේකෙන් ලොකු දෙයක් කරගන්න පුළුවන්. මේ දුන්න ඔක්කොම ටික symbol එක මතක තියාගත්තම ලේසියෙන්ම මතක තියාගන්න පුළුවන්, right? okay. then දැන් මේ ටික මෙතනින් මම ඉස්සරහට යනවා තව ටිකක්. so mass number කියන්නේ mass එක, right? එතකොට මේ mass එක හැදෙන්නේ මොනවද? මේ හැදෙන protons plus neutrons වලින්. protons plus neutrons වලින්. එතකොට atomic number කිව්වේ මේත් කිව්වේ number of protons ගන්න. right? number of protons ගන්න. එතකොට mass number එක මම capital M කියලා දාන්නම්. atomic number එක Z කියලා දාන්නම්. එහෙනම් the number of neutrons is going to be M minus Z, which means mass number minus the atomic number. Mass number minus the atomic number. Okay, I'll write that also. Mass number minus atomic number. Right? मैं खटपाඩම් කරන්න එපා. just හිතලා ගන්න තියෙන්නේ. okay, just හිතලා ගන්න. ඊට පස්සේ අපිට තියෙනවා isotopes ගැන කතා කරන්න මේකෙදී. isotopes. so මේ term එක iso කියන term iso කියන්නේ similar කියන එක, right? iso කියන්නේ similar. එතකොට මේකේ අපිට definitions දෙකක් තියෙනවා. You can write it with respect to mass number and the atomic number, and the other type you can write it with respect to the subatomic particles, right? So you need to write it like according to how they are asking you the question, right? If they are asking you to write the definition according to subatomic particles, then you need to refer to the protons, neutrons, right? And if they are asking you to refer to the mass number and atomic number, then you need to refer them, right? So I'm not going to give you the definition. You need to remember them. Huh? So this is some sort of a, a short note type thing. I'm not going to write the definitions. You need to find them. Okay. Then the most important part of this thing is right. මම මේකත් චුට්ටක් discuss කරලා දෙන්නම්. How the identification was done, right? Identification. So for this, an equipment called mass spectrometer was used, right? Mass spectrometer, right? So the thing happening here is that this will fragment, or it will break any sort of molecule into its different types of fragments, right? Breaks into different fragments according to M over Z ratio. Right? M over Z ratio means mass over charge ratio. So for your level, there's no need of knowing this method, right? In your A levels, we will be discussing about these spectrometric methods. So for the moment, just remember, මෙයාව මේ විදිහට එක එක M over Z ratios වලට තමයි කඩන්නේ, right? So then it will be identifying these M over Z fragments, right? And you will be getting a graph something like this, right? You will be getting a graph. So in this direction and this direction. So this is the data interpretation I'm going to tell you, right? Make a HANA exam, but instead of that giving the abundance value, they might give you this sort of a graph, and you need to calculate the abundance, right? That's why I'm giving you still make a halane ara condenser එකේ අර curved tubing එක වගේ තමයි. මේක තාම අහලා නැහැ, but අහන්න පුළුවන්, right? So here the y-axis, and so here it will be the abundance percentage, right? Abundance percentage. And x-axis will be the M over Z ratio, right? එතකොට අපි හිතමු මෙන්න මේ විදිහට අපිට lines and graphs එන්නේ මෙන්න මේ විදිහට, right? මෙහෙම එකක් එනවා. Just this is an example. අපි මෙහෙම ගමු. මෙහෙම එකයි ඔන්න ඔහොම එකයි just තව ඔන්න ඔහොම එකයි. Right? So here the abundance values let's say මේක එක abundance value එකක් මේක එකක් අනිත් එක මේක. Right? So here you can see there are three isotopes actually. So I'll say this is the first isotope, second, third. And the abundance values, I'll say like this is to be something like, let's say, all right, this is 90%, and this is 7%, and this is 3%, right? So the graph is something like this. Okay. So the calculation, the abundance values, right? The most probable mass value into 100% will be equal to the total summation of mass of an isotope into its abundance, right? So this is the calculation equation. It won't be given in the exam. You need to remember it. Okay? මේක මතක තියාගන්න ඕනේ. And also remember the abundance value must be equal to 100. ඒ කියන්නේ abundance එක a total of abundance ඒ කියන්නේ දැන් මෙන්න මෙතන abundance එක බලන්න මේ දැන් අපි ගාව පළවෙනි isotope එක තියෙනවා. එයාගේ abundance එක 107යි. ඊට පස්සේ දෙවෙනි isotope එක තියෙනවා. එයාගේ abundance එක 190යි, 90%. And the third abundance the third isotope, the abundance is 3. But if you add these three abundance values, you can see 90, 97, and 100. So the total of abundance values must be 100. Okay. So for example, මම example question එකක් කරන්නම්. මේක මම දන්නේ හරිම values නෙමෙයි මම මේ use කරන්නේ. අපිට මම example එක බලන්න මෙතන textbook එකේ තියෙනවා. Alright. So example එකක් තියෙනවා. මෙන්න මේ විදිහට boron වල right boron වල isotopes දෙකක් තියෙනවා. එකක් boron 10 අනිත් එක්කෙනා boron 11. ඊට පස්සේ මේගොල්ලගේ abundance values දීලා තියෙනවා right. So boron 10 having 20% abundance and the other one having 80% abundance. So they are asking what is the most correct relative atomic mass value, right? So which means we need to calculate the AR value, right? So AR value will be equal to, now you need to calculate for each isotope, right? So the mass of the first isotope B10 is going to be 10, abundance value 20%. So this is the first one. So, right? Plus, the reason is you are going to get the summation value. And the second isotope mass is 11 into 80%. Then divided by 100. Okay. Then divided by 100. So the answer here is 10.8. Answer is 10.8. එතකොට මේ answer එක ආවම ඔයාලට මේකෙන් තව පේන්න ඕනේ දෙයක් තියෙනවා. Right? ඒක තමයි two main points are there. Right? Remember them. If you are getting, you need to check your answer according to these conditions, right? So the first condition is that, right, AR value must be in between the isotope values. AR value, the final AR value must be in between the two isotope values. See, පළවෙනි එක්කෙනාගේ value එක 10යි, right? දෙවෙනි එක්කෙනාගේ value එක 11යි. එතකොට අපිට ආපු answer එක 10.8. So which means in between these two values, right? If you are getting a value below 10 or higher 11, then your answer is wrong. ඒ විදිහට මතක තියාගන්න. ඔයාලට තියෙන isotopes තුනක් තියෙනවා නම් එහෙනම් ඒ isotopes තුනේම lowest value එකයි highest value එකයි මැද value එකක් තමයි ඔයාලට එන්න ඕනේ final AR value එක විදිහට. එහෙම නැත්නම් ඒක වැරදි. Right? And the next point is, right? AR value is more closer to the value of higher abundant isotope. AR value එක final AR value එක ඒක ගොඩක් closer to the මොකක්ද මේ abundance එක වැඩි එක්කෙනාට, right? දැන් අපිට ආවේ 10.8. දැන් මෙතන abundance එක වැඩි 11 කියන එක්කෙනාගේ, right? එහෙනම් අපි calculate කරන AR value එක මෙන්න මේ ආසන්නයෙන් තියෙන්න ඕනේ. ඒ කියන්නේ finally කිව්වොත් මේ points දෙකම එකට කිව්වොත් අපේ AR value එක 10 and 11 මැද තියෙන්න ඕනේ. ඒ කියන්නේ අපි calculate කරන isotopes දෙකේ masses දෙන්න අතරේ තියෙන්න ඕනේ. හැබැයි must be closer to the higher abundant වලින්. දැන් අපිට ආවේ 10.8 නේ. ඒතකොට 10.8 කියන්නේ මෙන්න මේ හරිය. right? 11 වලට ආසන්නයි. right? 11 වලට ළඟයි ඒ දෙන්න අතර මැද. right? ඔන්න ඔය points දෙක නම් මතක තියාගන්න ඔයගොල්ලන් calculation එක ඒ කියන්නේ හරියටම confirm කරගන්න පුළුවන් මේක හරිද නැද්ද කියලා. right? confirm කරගන්න පුළුවන් හරිද නැද්ද කියලා මේකෙන්. මේ method එක මතක තියාගන්න. ඊට පස්සේ isotopes වලින් පස්සේ අපිට යන්න පුළුවන්. ඒ කියන්නේ තව මේකේ ගොඩක් දේවල් තියෙනවා. ඉතින් කතා කරන්න. isotopes වල මොකද්ද? අර neutral right මම එකක් කතා කරන්නම්කෝ. ඊට පස්සේ මේ isotopes වලට එද්දී අපි චුට්ටක් මෙන්න මේ ions ගැන discuss කරන්න ඕනේ. So here we are having two different main types of ions, positive ions and the negative ones. So the positive ones are being made by removing electrons, right? Removing electrons. එතකොට අපිට ලියන්න පුළුවන් M කියන එක්කෙනාගෙන් electron එකක් remove වුණාම මෙතනින් හැදෙනවා M plus 1 එකක්, right? බැරි වෙලා හරි මෙයාගෙන් electrons දෙකක් remove වුණා නම් මම ගන්නම් capital M ආය ගන්න. මෙයාගෙන් 2 electrons remove වුණොත් මෙයාගෙන් හැදෙනවා M2+. මොකද reaction එක balance වෙන්න ඕනේ, right? ඊට පස්සේ negative one එක ඒක වෙන්නේ gaining of electrons. For example, M කියන එක්කෙනා electron එකක් එක්ක එකතු වුණොත් so you will be getting the negative one. If it is going to get 2 electrons, then it will be 2 minus, right? Then, so remember, ඊට පස්සේ ions වලින් ඔයාලට calculations දෙන්න පුළුවන් මෙන්න මේ වගේ දේවල්. So let's say magnesium, right, having 12 atomic number, 24 mass number and forming the +2 ion. So now they can ask the number of protons, number of neutrons, number of electrons. So number of protons will be directly equal to the atomic number, right? Normally we cannot remove protons. Protons කියන එක අයින් කරන්න බෑ. ඒක නියුක්ලියස් එකේමයි තියෙන්නේ. අයින් කරන්න බෑ කියන එක 100% correct නෑ. මොකද protons වෙනස් කරන්න පුළුවන්. But it requires a huge amount of energy. But your level, just remember protons cannot be removed. So therefore, the number of protons will be directly given by the atomic number. So in this case, so therefore, the number of protons will be equal to 12. And the number of neutrons, so here it will be mass number minus the atomic number. I'll write Z, right? So it will be 24 minus 12, which is 12. And now the number of electrons. So when you are getting number of electrons, see here, this is plus 2, which means, so plus 2 means, right? In order to make the plus ions, you need to remove electrons, right? So if you are going to make the plus 2 ion, which means 2 electrons are removed, right? 2 electrons are removed. So already had 12, 2 electrons are removed. So therefore, the number of electrons will be 10, right? The number of electrons will be 10. Okay, so remember these things. And if it is a negative ion, then you need to add electrons. Okay, මම ඒකත් ඕනනම් චුට්ටක් මෙතනින් mention කරන්න. Let's say something like O2 minus. So the number of protons directly 8, number of neutrons again 8, right? I'm not going to give you the calculation, but the number of electrons, so here it will be 8 plus 2 going to be 10, right? චුට්ටක් ඒක හිතලා බලන්න කොහොමද ඕවා එන්නේ කියලා, right? And I did some examples, like some good examples of hydrogen isotopes, right? Protium, deuterium, and tritium. So refer the notes and see what are the main points that you need to grab from those things. Okay. Then the last subtopic that we are going to discuss here today under this section will be the periodic table part. Okay. So far, right. So before starting this section, yeah, tell me whether you are having any sort of troubles. මොනවා හරි questions තියෙනවා නම් මට chat box එකට දාන්න. අද මේ microphone මේ headset එක නෑ මං ගාව. So therefore I can't hear anything that you say, right? If you are having any question, just drop a message in the chat box, right? අවුලක් නැත්නම් thumbs up දාන්න. එතකොට අපිට ඉස්සරහට continue කරගෙන යන්න පුළුවන් periodic table part එක ඉවර කරන්න පුළුවන්. Yes. Good. And if you are having any trouble, just drop a message, okay? Right. We'll continue. So the last, yeah. Yeah. So here, structure of matter, atomic structures, and the periodic table. So we'll try to finish this first branch today. Okay. Periodic table. Right. So I'll briefly explain some special points here. So at the present, there are nearly 118 elements, right? And so element by element, it is not practical to remember their properties and uh, how they are going to, like, how they are going to behave, their reactions, like those things, right? So therefore we need to categorize these elements, like it's better, ne? So so we are categorizing the same elements in the same group, having the same reactions and having the same properties, right? So likewise, it is better if we can categorize and memorize it. අපිටම දැන් එකක් මේ විදිහට categorize කරනවා. මේගොල්ලන්ගේ පල්ලෙහාට යන්න යන්න රියැක්ෂන් එක වැඩි වෙනවා, රියැක්ටිවිටි එක වැඩි වෙනවා. එහෙනම් අපිට එතකොට අර මොනවද එලිමන්ට්ස් ටික පල්ලෙහාට මතක තියාගත්තා නම් එහෙම හරි. නැත්නම් one by one remember කරගන්න එක, මතක් කරගන්න එක එච්චරම ප්‍රැක්ටිකල් නෑ, right? So ඒකයි අපි periodic table එකක් prepare කරන්නේ. So that is the main idea, the first idea that you need to have, right? ඒක idea එක තියෙන්නම ඕනේ. ඇයි අපි මෙහෙම table එකක් හදන්නේ කියන එක, right? ඇයි අපි මෙහෙම table එකක් හදන්නේ කියන එක, right? So I will write it here. Why? ඇයි අපි table එකක් හදන්නේ? අන්න ඒක හොඳට idea එක දාගන්න. So the reason is for the easiness of studying about elements, right? For the easiness of studying the elements, right? So 118 elements, so there were different types of periodic tables in history, right? ඔය දැන් තියෙන එක නෙමෙයි එකපාරට ආවේ. මේකත් ඇවිල්ලා මොකද අර evolution එකක් through ගිහිල්ලා තමයි මේක ඇවිල්ලා තියෙන්නේ. So the scientist who invented this is Dmitry Mendeleev. Just remember those points, okay? And right. Then the main thing that you need to remember when it comes to a periodic table is that the naming of groups and periods, right? So if we consider, let's say, the table to be like this, right? Then if we are considering in, let's say, in this manner, right? Like this, in the vertical direction. So they are known as groups, right? If you are considering downwards, they are called as groups. And if we are considering in this direction, they are known as periods. They are known as periods. So that is the most important one, right? Groups and periods, you need to remember, okay? Groups and periods, right? So in the modern periodic table, you have 18 groups, right? I'll draw it like this. You have 18 groups, and when it comes to periods, you have 7 periods, right? 18 groups and 7 periods. In your A levels, you will know how these 18 groups and 7 periods are being made, right? For your level, just remember the numbers. That's enough, okay? And then we need to know how the elements are being embedded into this table, right? How the elements are arranged. How the elements are being arranged. So for this, we are using something called uh, the electronic configuration, right? Electronic configuration. So here I'll write it. We are using according to the electronic electronic configuration, right? We are using the electronic configuration of an element. We are using an electronic configuration of an element to place the elements in the periodic table, right? Now we are having a trouble. What is meant by the electronic configuration, right? What is electronic configuration? So we can say the arrangement of electrons in an atom. The arrangement of electrons in an atom, right? The arrangement of electrons in an atom. So here, the arrangement. So previously we discussed like these electrons will be arranged in their energy levels, right? Atomic levels, energy levels, right? Not atomic levels, energy levels. So when it comes to these energy levels, uh, there are so many concepts about that, right? You will learn them in your A levels. So for the moment, just remember there's a specific number of electrons that they can occupy, right? There's a specific number of electrons that they can occupy. Specific number of electrons that can be occupied in an energy level, right? So this number of electrons for your level, right? It will be 2 for the first level, 8 for the second level, and 8 for the third level. But the actual number is 2, 8, 18, and 32, right? No need of knowing that thing. For your level, this is enough, right? For your level, we will be considering only up to the first 20 elements, right? First 20 elements, which means like the next number would be 2882, right? The first 20 elements, that's enough, okay? No need of knowing the other ones. So which means, for example, let's say if I need to write the electronic configuration of sodium, right? Having 11 electrons, so it will be 2, 8. So up to this place, 11 electrons are being filled. Sorry, 10 electrons are being filled. Then it will be 281, right? So this is going to be my first energy level, second energy level, and this is going to be the third energy level, which means for sodium atom, you will be having 3 circles around the nucleus, 3 energy levels around the nucleus. And another example, let's say something like calcium having 20. So it will be 2, 8, 8. So up to this place, it is 18 and 2. So which means here you are having 4 energy levels, right? 4 energy levels. So these are some uh, easy numbers, right? Easy things. And yeah, so they will be arranged according to the electronic configuration, right? So here, according to the electronic configuration means elements, right? The elements will be categorized according to their group, according to their group. So how to predict the group? So that is the main thing that we need to know, right? How to predict the group and the period. How to predict the group and the period, right? How to predict the group and the period. So this is how we are going to predict it. So for example, I'm going to use calcium, which is having 20 electrons. 2, 8, 8, and 2. So this is the electronic configuration for that. Okay, that is the electronic configuration. So the last digit, right? The last digit. So it will give you the group number. This is the group number. And the total number of digits. So here there are 4 digits, right? 2, 8, 8, and 2. So this will give you the period number. So if we consider the periodic table, like this, right? If we consider the periodic table, so the groups at your level, we will be considering only 8 groups, right? So I'll write 1, 2, 3, 4, 5, 6, 7 and 8. And the periods 1, 2, 3, 4, 5, that's enough, right? So calcium, right? So according to this, calcium will be in the second group, fourth period. Second group, fourth period. So second group, fourth period at this place, right? So calcium will be here. Another example, we'll say we are taking sodium. So 281. So this is the group number, and the total number of digits here will be the period number, right? So therefore, it will be first group, third period. So group 1, third period. Sodium will be here, right? Likewise, you can calculate the exact position of an given element, right? Of an given element depending on the electronic configuration, right? Electronic configuration, right? Then when it comes to this periodic table, actually there are different names given, right? For example, let's say for the gases, that helium, neon, argon section, it will be named as the noble gases, right? And yeah, I'll write that also here. So there are some special names given, right? Uh, for the group 8, that is known as the noble gas group, and seventh group, that is known as the halogens, and the first group, alkali metals, and the second one, alkali earth metals. And even for sixth group as well, you are having different names, but for your level, only these four names are enough, okay? Right. Then there's a difference between that staircase difference between the metals and non-metals, and there are some what do you call that properties of metals and non-metals as well, right? So for homework, right? So this is the part that you need to engage here, right? So the first question is identify the separation between identify the separation between metals and non-metals, which means I'm asking the point that the staircase starts, right? And the second question, properties of metals versus non-metals. Properties of metals versus non-metals, right? There are some specific properties, right? So for metals, I'll give one or two here, right? So for metals, just remember for the metals, right? Then the same opposite thing, right? The opposite version will be for non-metals, right? So for the metals, definitely they will conduct electricity. Conduct electricity. And definitely they are going to be basic compounds, right? Metals are always basic compounds. right? Whether they are forming oxides, hydroxides, or anything like that, they will form basic compounds. Remember that, right? Metals are always basic. So which means non-metals are going to be acidic, right? Non-metals will be going to be acidic. And there are some other properties as well, like malleable, ductile, and all those stuff. You can go through them, okay? Right. So that is up to that place. So there are some homework questions as well. So I'll upload this tut as well. You can the written note. You can either take a photocopy or print out or anything like that. I don't care, right? It's better if you can write it, right? So I will be uploading the as I mentioned, the lecture note, the recording as well, right? So it's better if you can prepare your note, right? So we completed this section, right? And hopefully, so the next week, the next session will be, the chemistry session will be on April 20th. So in that day, I'm trying to complete these two sections, right? Bonding, the chemical bonding part and electrochemistry part, right? Then afterwards, the next day will be 22nd. So at that day, I will be focusing on chemical calculations. Afterwards, we'll try to finish these sections, right? So time to time. Yeah, hopefully we will be finishing by April 29th. Okay. Right. So if you are having any trouble, just drop a message, a personal message or something like that. Then I can reach out to you guys. Okay. So I'll upload this note into the WhatsApp community as well. So you can either take a printout or you can refer the video and refer the recording, and you can prepare your own note. Okay. So that's all for today. And those who are joining the physics session as well, we will be starting the physics session and at 11 a.m. right? At 11. So you have 1 hour time period, and yeah, you can have a break, and you can join the physics session as well, right? Okay. So I'm going to stop the recording so you can have a break, and we'll start the session at 11 a.m. today. Okay. Right. Okay.